अच्छा, this one. Last time what we discussed was, यहाँ से start करते हैं. What we discussed was that you have an ionization chamber. How do you figure out relative atomic mass? So we figured out कि if I have Cl, the Cl atom is ionized, and those particles are then turned into a beam, and they're accelerated, and then they are deflected in a magnetic field. So the Cl ions which are formed are going to get deflected. Now, since not all the Cl atoms have the same mass. They could have a mass of 37. They could also have a mass of 35 as well. So some of them could be lighter, some of them could be heavier. So what is done is the lighter ones will be deflected more, and the heavier isotopes of Cl will be deflected less. So the deflection of the particles would be proportional to the charge of the particle, which is normally always +1, and inversely proportional to the mass of the particle. So we develop a relationship between deflection and mass. We calibrate it. So every time what we see is we see the deflection and we figure out the mass of the particle. This is how the relative atomic mass is measured. Because obviously there's no weighing balance. So what they do is they deflect it and they figure out what the mass is. So deflection is basically inversely proportional to the mass of the particles, which is why. So what happens is you've got a detector over here at this side, and it detects those particles at different angles. And so that deflection gives you an idea about the mass of the particles, and it also detects the number of particles that it's detecting. So if you have more of Cl35 isotopes, you're going to get a higher a higher detection rate. If you have fewer Cl37 particles, you'll have a fewer particles falling onto the detector, and there's going to be a smaller detection. So you will get a relative idea about how many Cl35s are you detecting and how many Cl37s are you detecting. If you get 3 particles of Cl35 and you get 1 particle of Cl37, you'll get the idea that there's a percentage abundance of 75% and 25%. ठीक है? जल्द ये clear है ये पिछला वाला part?
Yes, sir.
अच्छा, so you'll have that idea, right? And in IGCSE you did this formula, which is that the relative atomic mass is the average mass of all these isotopes. So it is, what you're going to do is, अच्छा, so it is the sum of the weighted average, which is the percentage of the isotope abundance times the isotopic mass. And you're going to divide the whole thing by 100. Yeah, that's the weighted average. 75% is Cl35 and 25% is Cl37. So you're going to take the average. And taking the average, this is the other method of taking the average. 75% of the Cl atoms were 35 plus 25% of the Cl atoms were having a mass of 37. And you then divide by 100. And if you do this, you do the math on your calculator, it's going to come out to be 35.5. Okay, that's the average mass of a Cl atom. Okay, ये clear है?
जी सर क्लियर है.
अच्छा, इसको ना we'll just do once again. So I'll open the worksheet that I just sent, and गलत group पे तो नहीं भेज दिया एक second. अच्छा, so yeah, this one. Not the marking key. That's the salt version. Okay, so we'll start doing questions on these. अच्छा ये हो गया. So I'll go back to कहाँ पे relative atomic mass. The theory part. It's on page 55. So we'll do those questions now. अच्छा, make sure you have a calculator with you. अच्छा, ये IGCSE में you did questions like these. अच्छा, so again, remember what you're going to notice is, अच्छा, make sure you know the difference. The difference that I'm talking about is that you should know that this thing over here is the nuclear number. If it's a whole number, that's the nuclear number. The isotopic mass is in decimals. You can remember I told you early on, okay, the nuclear number is uh, you're counting the nucleons, so that is always a whole number. But the mass is something that is not going to be an exact number. It's going to be something that's in decimals. It's going to be very close to it, but it will be something in decimals. I said now he's saying that there is इसका नाम क्या है? Cerium. ठीक है, there's a cerium atom. It's got four isotopes, and it's got four isotopes, and he has no idea about what this is. And he's got the relative atomic mass. He's already done. He knows what the answer is. It's 140.116. He's asking you to calculate the relative isotopic mass of the fourth isotope. So I'm going to take this as the isotopic mass. I'm going to take this as X because I don't know what it is. So the percentage abundance, I know what the percentage abundance is because the total percentage abundance is going to be 100%, right? So if you subtract either calculator पे करो, okay, what do you get? Because the total percentage abundance, it should be 100%. So what is the missing percentage over here? Jannat Ghazi, can you calculate this?
Yes, sir. I'm working on. Sir, it's 11.114 for me.
11.114%. Okay. So it's 11.114%. Now, we already know what the AR is, which is the average of all the isotopes, the 140.116. How do you calculate that? It's the percentage multiplied by the isotopic mass plus the percentage, so all of them added up together, right? So it's going to be 0.185, and that's going to be multiplied by 135.907, plus it's going to be 0.251, and that's going to be multiplied by 137.906, plus it's going to be 88.45 multiplied by 139.905. Okay, so all of that. And then it's the last one, which is X, and that will be multiplied by 11.114%. And the whole thing will be divided by 100. Okay, so you have to solve for X now. Achha, ye AS ka na, there's this one big problem that sometimes you get simple addition and subtraction, but you get a lot of values to add and subtract. So try doing this and try and find out what X is. इस तरह की जो आएगी ना, उसमें there's a very bright chance that you'll just make some error on your calculator. So ये try करो, find out what the answer is for this. And you have to be intelligent because you have to have some idea about what X should be. Well, the 142 is the nuclear number, so it should be something very close to 142. So remember calculator पे ना, you should do a lot of calculations ताकि you develop that speed. A lot of people are actually not good at using calculators. आगे किसी का आंसर या नहीं?
Then I am working on it.
ठीक है गाजिया, that's the answer. 141 point. अच्छा, तो बस एक चीज उसमें एडवाइस थी कि just do a lot of calculations on the calculator, because वो इतनी लंबी चौड़ी मल्टीप्लिकेशन डिवीजन सब्ट्रैक्शन वगैरह होगी ना, तो that will waste a lot of time as well. Remember, time is very important. You have to do things very quickly. तो ये प्रैक्टिस करनी है, ठीक है? अच्छा, now one thing about this one, I'm just going to tell you something which is not really directly related to this, but it's related to calculations. Okay, so some tips related to how you should solve the answer. अच्छा, sorry, मेरा वो tab disconnect हो गया, just 1 second, connecting again. एक सेकंड रुकना, connect हो रहा है. अच्छा, so ठीक है. Some tips about, not tips, but बल्कि you have to be noting these things. Okay, what should be, you should be careful about these things. The first thing is, how many, while you're doing math, how many significant figures should you use? So now the first thing is, what is the difference between 2.1 and 2.10 and 2.1000? अच्छा, quickly बता दो इसमें, what's the difference between these three values? कोई idea? जन्नत गाजिया, any idea?
There is the zeros at the end, but aren't they all consisting of two significant figures?
नहीं, they're not. The first one is two significant figures.
Right. Okay.
The second one is actually three significant figures. And the third value is actually 1, 2, 3, 4, 5 significant figures. अच्छा, but the important thing is कि value में क्या फर्क है? I mean, aren't all of them 2.1? I mean, they are 2.1, right? So, what does the significant figure, why does it make a difference? वैसे ही मैं खुद ही आंसर कर लेता हूँ कि the thing is, over here, you're not sure what comes after 2.1. Well, it could be 2.13, could be 2.15, could be 2.11. You have no idea. What's coming after that? You have no idea what comes after that. Either you know that it's I mean you know that it's this is 2, this is point 1, and this is 0, but you have no idea what comes after that. Okay, so significant figures, they tell you what the accuracy is. So this number over here is less accurate because you're only sure about the first two numbers. You don't know what comes after that. And this number over here is more accurate. Or remember, they're not the same number actually. Over here, you know that this is 2.1, and then there is 0, there's another 0, and there's another 0. Over here, you know that this is 2, this is 1, this could be 5, this could be 8, this could be 2, this could be 3. You have no idea. So remember this, these two numbers are not actually the same number. Calculating ki nazar mein na, it's the same number, but otherwise they're not the same number. One of them is very inaccurate and the other one is more accurate. ये बात clear है? Is this clear?
जी सर.
अच्छा, अब मुझे बताओ कि I've got two numbers. I've got 2.1, and that's being multiplied by 4.234. ठीक है, that's how they're getting multiplied, right? Calculator पे पहले तो calculator पे answer करो. What's the answer? 2.1 multiplied by 4.234. First number is two significant figures. The second number is accurate up till four significant figures.
So the answer
अच्छा
is
क्या है?
8.
8 point
Yeah.
8.8914, right?
8914.
अच्छा, अब जो important चीज है ना वो ये कि one of the numbers had an accuracy of two significant figures. The other one had an accuracy of four significant figures. The first number, you had no idea what came after that. It could have been 2.13, it could have been 2.135. You have no idea what it is. You just know that it's 2 and then it's 0.1. Uske baad you have no idea. Now tell me, what would be the accuracy of the answer? I mean, your answer is, I mean, at the moment, the calculator says that it's five significant figures, right? So, मुझे talk if in the first number you have no idea what the third number is, how could in your answer, I mean, in the answer, the number that you're getting using that number 2.1, you should not be sure about what these numbers are. मतलब question mark है ना, मतलब ये पता ही नहीं है. I mean, the calculator is assuming that that's 0, but maybe that is not 0, right? So the rule is that if you multiply two numbers which have different significant figure accuracy, your answer will follow the least significant figure accuracy. So it's going to be two significant figure accurate. So you're going to round this up to 8 point, round it up till the second significant figures. क्योंकि अगर original number भी नहीं पता ना कि what comes after the second number, right? How can you be sure about what comes after the second number in the final answer? But does that make sense? चलो तो गाजिया, ये clear है?
Yes, sir. Yes, sir.
ठीक है. तो calculator जो है ना, that is just assuming that that is 0, but we're not sure that that is 0, right? So which is why we're not sure about these three numbers. So you always round it up till the. So remember this, during multiplication and division, during multiplication division, the least significant figure accuracy is followed. अच्छा, now the same thing. What happens during addition and subtraction? So I've got बल्कि बड़े को छोटे से subtract करते हैं. I've got 4.234 and I'm subtracting 2.1 from it. मुझे बताओ calculator में what do you get?
Sir,
इसीलिए
2.14,
2.1
2.134.
134, right? अच्छा,
Yes.
again, so again, there's a problem with the calculator, which is that it is assuming that this is zero. हमें तो पता ही नहीं है कि it's zero. I mean, we have no idea that this is zero, right? बल्कि for us it's a question mark. No idea. ना कभी पता लगेगा कि 2.1 के बाद क्या आना था, कुछ पता नहीं. So the point is, these two numbers, they don't make sense. ठीक है? So during addition and subtraction, the rule is slightly different. Least decimal places are followed. Your answer should have the least decimal places. Well, for example, if this was 3 decimal places and this was 1 decimal place, right? So your answer would be accurate up till 1 decimal place. बाकी दो का तो फायदा ही कोई नहीं है क्योंकि I have no idea what those question marks are, right? So is this part clear? तो a simple सा rule है, which
सर
is that
लेकिन सर ये रूल तभी अप्लाई होता है जब आप आंसर लिख रहे होते हैं, लाइक दी फाइनल आंसर, या जब आप कैलकुलेशन कर रहे होते हो तब भी?
नहीं कैलकुलेटर तो कर देगा ना, वो तो ज्यूम करेगा जीरो है. ठीक है, मतलब कैलकुलेटर तो कैलकुलेशन कर ही नहीं सकता अगर वो क्वेश्चन मार्क होता ना, फिर वो क्या करता, वो कुछ भी नहीं कर सकता. तो कैलकुलेटर तो there's something, there's inherently something wrong with the calculator, which is कि वो assume करता है this is zero. ठीक है. So but the problem is during multiplication and division is कि you always follow the, if this is 2 significant figures, this is 4 significant figures, your answer should be written up till 2 significant figures. उसको अगर 4 significant figures तक लिखोगे ना, that is wrong. And during addition and subtraction, if one of them is 3 decimal places, the other one is 1 decimal place, you're going to write your answer up till 1 decimal place. ठीक है, तो दो simple से rules हैं. ये clear है? Most of the time, sometimes Cambridge is going to cut marks for that. ठीक है? Uh, they have cut marks for that, especially in practicals. क्योंकि वहाँ पे different apparatuses have different accuracy. So you have to be, and significant figures is basically accuracy. मतलब एक thermometer है which is up till 1 decimal place, right? It can give you a reading of 4.1 degrees centigrade or 4.3 degrees centigrade. So that means the thermometer is 2 significant figure accurate, right? There's another thermometer which could only tell you whether it's 4 degrees centigrade or 5 degrees centigrade, nothing in between, right? So that's just 1 significant figure accurate, ठीक है? So accuracy would matter and it will matter in practicals, ठीक है? तो ये चीज क्लियर है कैलकुलेशंस में?
यस सर.
अच्छा, plus I'm going to tell you one more thing, which is another tip is while you're calculating, and that is avoid rounding errors. So what are rounding errors? If you have multiple steps, step one, and then there's a calculation, and you go to step number two, and then you have another step, which is step number three. So make sure कि, but I mean, take whatever the calculator is giving you, take that number forward. ठीक है? Then calculator gives you another number, take that number forward. ठीक है? The rounding has to be done right at the end. मतलब बीच में राउंडिंग नहीं करनी. ये बात समझ आइए?
जी सर.
Varna, that's you're going to get rounding errors. Okay, don't round answers in the middle of the steps. हाँ अगर पेपर पे लिखना होगा ना you're going to round them off. But if you're doing this, right, and you have to write it on the paper, right, you're going to write 2.1. Lekin don't round it off on your calculator. Like if the same value is being used in another calculation after that step, you take the same value forward ताकि वो बीच में ना you don't get a rounding error. So don't round answers in the middle of the steps. But at least not on your calculator. Paper पे लिखते हुए you're going to round it off up to the appropriate significant figures. Right? Is that clear?
Yes, sir.
अच्छा ये हो गया. So going back to our question, which is we got this, okay? And he in this case he told us that it should be 3 decimal places, right? That my answer should be 3 decimal places. So we be using that. And so moving on to the next one. He's saying define the terms relative atomic mass. So we did that. It's the what is it? It's the average. We'll cover average mass of an isotope of an atom compared to 1/12 the mass the यहाँ पे आना चाहिए mass of carbon 12 atom. ठीक है isotope you already know. The isotope क्या होता है? It's atoms of the same element having the same proton number but different nuclear numbers. इधर अगर गलती से भी isotopic mass लिखा ना या relative atomic mass लिखा तो गलत होगा. Same proton number but different nuclear numbers. I say you got this one, and he's saying you have to find the relative atomic mass, and he's told us that it should be up till 2 decimal places. You have to be careful about the decimal places that he's asking for. So यहाँ पे ये बस एक कर लेते हैं. We're not going to waste too much time on this. 0.89, I think it's 0.89% times 74 plus 9.37. कैलकुलेटर पे स्पीड बढ़ाने के लिए ना ये चीज एक्सरसाइज अच्छी 7.63 times 77 plus 23.77 times 78 plus 49.61 times 80. अब वो एक ही डिफरेंस है आईजीसीएसई और इसमें कि यू हैड द सेम क्वेश्चन बट यहाँ पे ना बस वो आपका टाइम ज़्यादा ज़ाया कर रहे हैं 8.73 times 82 and divide the whole thing by 100. ये बताओ कि what do you get? 79.0421 उसकी बात भी फॉलो करनी है. I think he was talking about 2 decimal places. So क्या कहा था उसने? I think he said 2 decimal places, right? So 79.04. Yeah, that's what our answer is. और थोड़ा सा ना मैंने you should because remember you can go wrong with the calculation, so you should have some idea about some guesswork. कि सबसे ज़्यादा value इसकी है ना this 180, right? So it's probably going to be somewhere in the middle over here. The average would come out to be somewhere. So ठीक आ रही 79.04. That kind of looks good. And so it's kind of there's not a lot of variety of questions. Most of them are kind of exactly the same. इसमें बस एक आध देख लेते हैं if there's any tricky ones. नहीं वही है, बस वही चीज चली जा रही है. होल्स कहाँ से आ गए एक second. अच्छा वो दूसरे क्वेश्चन आ गए. चलो ठीक है. मतलब ये क्लियर है ना, दिस इज यू डिड दिस इन आईजीसीएसई एज वेल. इज दिस क्लियर?
Yes, sir.
गाजी अब चलो ठीक है. अच्छा अब इसमें what you didn't do in IGCSE, we're going to talk about that. So there's a thing called, we're going to talk about isotopes of Cl. As I remember, when it comes to isotopes, normally atoms don't have a lot of isotopes, especially the common ones. जिस तरह हाइड्रोजन है ना, उसको if you google the isotopes of hydrogen, ठीक है, कर लेते हैं Google एक second. अच्छा if you google the isotopes of hydrogen atoms, so atoms don't have, ये कर लेते हैं, they generally don't have a lot of stable isotopes. For example, this is hydrogen, and then you've got deuterium, which is the one which has one more neutron. Or वो hydrogen 3 जो है ना, that's tritium, right? So the percentage abundance, like 99.9, almost 99% of all hydrogen atoms are hydrogen 1. The other ones you can't really find the other ones. Hydrogen 3 जो है ना, you can't even, वो तो trace है, उसका मतलब है वो तो मिलेगा ही कभी नहीं. So normally atoms have isotopes, but they are not very abundant. But with Cl, the thing is that it's got an isotope. It's got two isotopes which are like really, really abundant. And Cl is something that is very common, and a lot of compounds have Cl in them. So Cl has two isotopes. One of them is 35, and the other one is 37. The chances of getting Cl35, 75% of all atoms of Cl are Cl35. 25% chance is of getting Cl37. In probability, this is 3 by 4, and that is 1 by 4. So remember our mass spectroscopy, there was a beam of Cl atoms, ions, and you were getting two deflections for Cl. One of them was the lighter one. It was Cl35, and the other one was the heavier one, which was Cl37. And there was a 3 by 4 chance of getting this, and there was a 1 by 4 chance of getting the other one. Okay, we did that. तो मतलब अगर ये आपको ये वाले लेट्स से 75 मिलेंगे, तो ये वाले कितने मिलेंगे? These would be 25, right? अच्छा, now what if I do the mass spectroscopy of a Cl2 ion? यानी अब एक molecule है, ठीक है? I'm trying to do the mass spectroscopy of that. I'm going to turn that ion or a beam of ions, and there would be these beam of ions of Cl2 molecules, ठीक है, rapidly moving and then getting deflected in the magnetic field. मुझे बताओ, how many different masses would Cl2 have? How many deflections would I get? मतलब ये याद रख लो कि just to be clear, there are two types of Cl. There's 35 and there's 37. तो बता Cl2 की कितनी different masses होंगी? जन्नत गाजिया क्या होगा? How many different masses? 4? 8? 8 तो बहुत ज्यादा हो गया. 3 होंगी. वो बता देता हूँ, there'll be 3 different masses. 3 different masses and 3 different deflections. There's going to be a lighter version of Cl2 plus, and there's going to be a heavier version. So the lightest version of Cl2 plus. So both Cl atoms will have a mass of 35. So in total, it's going to have a mass of 70. I said, then there's going to be a slightly heavier Cl2 plus 1. So one of the Cl would be 37, and the other Cl will have a mass of 35. So it will have a mass of 72. So there's going to be a slightly heavier version of Cl2 plus 1. And then there's going to be a particle of Cl2 plus 1, which would be very heavy. And that's going to be made up of two Cl atoms. Both of them are going to be 37, and that will have a mass of 74. यानी तीन different masses होंगी Cl2 plus. It's either going to have a mass of 74, it's either going to have a mass of 72, or it's either going to have a mass of 70. Is this clear?
Yes, sir.
ठीक है. अब इसका probability क्या होगी? What is the percentage abundance of detecting 70? What are the chances of detecting 72, and what are the chances of detecting 74? I say if you have studied probability, basic probability, 35 आने के chances क्या होते हैं? मतलब क्या probability? 3/4, right? 75%, right? Out of all the Cl, there's a 3/4 chance of getting Cl35, and there's a 1/4 chance of getting Cl37. अच्छा, अब आ जाओ इस पे. What are the chances of getting both atoms, दोनों के 35 आने के chances क्या होंगे? So the chance of getting Cl35 was 3/4, and the chance of getting the other Cl atom being 35 again is also 3/4. So जब वो and आता है ना, the probabilities they get multiplied. मतलब for example, वो dice आप roll कर रहे हो, 1/6 chance of getting 6. Next, if you get another 6, that's also 1/6 chance. So the probabilities are going to get multiplied, and the chances of getting 70 is now going to be 9/16. ये clear? यानी out of 16 events, or out of 16 detections, 9 of the particles are going to be having a mass of 70. ये clear है? ये चीज
Yes, sir.
उसी समय बाकी दो का भी हिसाब लगाओ कि क्या होगा. 74 ऊपर वाला कि 37 आने के, what are the chances of getting 37? That's 1/4. और दूसरा भी 37 आ जाए, वो भी 1/4. So that's going to be 1/16. So that means कि 74 वाला जो डिटेक्ट होगा ना, ये तो बहुत कम डिटेक्ट होगा. There's only, out of 16 detections, there's only a one chance of detecting 74. अच्छा, तीसरा वाला ना, what you can do is you can just subtract the other two. मतलब 16 events है ना, एक इधर चला गया, 9 इधर चला गया, पीछे कितना रह गया, 6. So that means that will automatically be 6/16. और अगर probability में ज़्यादा ही है ना, तो there's a 1/4 chance of detecting 37, and there is a 3/4 chance of detecting 35. लेकिन इसके ना दो इवेंट्स होंगे. वो दो इवेंट्स इसलिए कि या तो पहला वाला, the first one is 37 and the second one is 35, or the first Cl is 35 and the second one is 37. So basically दो particles होंगे which will have a mass of 72. Either the first one is 37 and the second one is 35, or the first one is 35 and the second one is 37. तो इसलिए वो दो events होंगे. That's why I'm multiplying it by 2. Yeah, लेकिन simple probability है कि this is 1/16, this is 9/16. तो 16 में से 10 तो ये हो गए, 1 उधर गया, 9 इधर आया, पीछे से you're left with 6/16, right? So what you've done is you have figured out the detections or the percentage abundance of Cl2 plus 1. Because Cl2 plus 1 you're doing mass spectroscopy, this is going to be, you'll detect something at 70, you'll detect something at 72, and you'll detect something at 74. And the abundance of the percentage abundance would be, it would be 9 out of 16, 6 out of 16, 1 out of 16. So the ratio would be 9:6 रेशो 1। ठीक है, इज दिस क्लियर?
Yes, sir.
Yes, sir.
तो ठीक है, बस ये याद रखना है अभी। इसका कोई भी इतना काम अभी फिलहाल नहीं होगा। लेकिन सिंस वी आर डूइंग mass spectroscopy, you got to remember that it's if you have two CLs, it's going to be you're going to have three peaks, and the three peaks will have a relative height of 9:6:1, which is basically the relative abundance। ठीक है, तो चलो फिर ये नेक्स्ट टाइम फिर हम कंटिन्यू करते हैं यहाँ से। ठीक है।
There was a question है जो Cl2 है.
हम्म।
Uh, why does it have like a charge? We've not studied anything like this in O levels के
नहीं
diatomic पे
नहीं,
charge.
एक तो वो है कि इसको जबरदस्ती चार्ज दिया ना। किधर गया हमारा डायग्राम? ये था ना, आयनाइजेशन चेम्बर था ना। सीएल के ऊपर तो -1 चार्ज होता है, नहीं तो हम जबरदस्ती वी बम्बार्डिंग इट विद इलेक्ट्रॉन्स, सो वी आर बेसिकली नॉकिंग आउट इलेक्ट्रॉन्स आउट ऑफ इट। मतलब वो आर्टिफिशियल चार्ज, इट्स नॉट इट्स एक्चुअल चार्ज। इट डजंट वांट टू बी +1। वो तो आयनाइजेशन चेम्बर है where it gets bombarded by electrons and you knock out electrons out of it। और वो जब आयंस बन जाते हैं तो we turn those ions into a beam and deflect it in a magnetic field। ठीक है, तो क्लियर है उसका मतलब उसमें असल में उसके पास ये चार्ज नहीं होगा, वो तो हम जबरदस्ती उसको उसके ऊपर ये चार्ज डाल रहे हैं। क्लियर है?
जी सर.
तो जो ठीक है, कंटिन्यू करते हैं नेक्स्ट टाइम। ठीक है, ओके, टेक केयर, हाफिज।